So we're given an f of x and a g of x, and we're asked a few questions about them. One of them being, what is f divided by g of x? And then what is g divided by f of x? Well, the first one, f divided by g of x, you literally say f of x divided by g of x, which is x cubed divided by 6x squared plus 7x minus 10. So then for g divided by f of x, that's just literally g of x divided by f of x. So you copy paste g of x. You copy paste g of x down, so 6x squared okay, but then the question goes further and it's asking for the domain. And domain is really asking what can x be. Domain is all x's, range is y's. And usually domain can be, in a lot of cases, it can be from negative infinity to infinity. But there's times when it's not. Okay, when it's from negative infinity to infinity, that's all real numbers. That means x can be anything at all. There's times when it's not, and this is a case because there's a fraction. When there's a fraction, we have to worry about the denominator because, and here's a little comment, no, you cannot divide by 0, but it's okay to have it in the numerator, but you can't have it in the denominator. So whenever we're asked about the domain of these rational functions, we're worried about the denominator because there are variables in the denominator. Variables variate. So we want to know what you plug in for that variable that makes it 0. So the g divided by f of x is fairly simple because the rule for domain is set denominator not equal to 0. So for the g divided by f, that's just x cubed not equal to 0. And how do you solve it when it says not equal to? Well, just pretend it's an equal sign. And I need to know what x equals. I know what x cubed equals, so you could technically take the cubed root of both sides. And the cubed root of x cubed is x. The cubed root of 0 is 0, okay? So in this case, interval notation, let's think about originally when it's all real numbers, it's from negative infinity to infinity. But we just found out for this one that x cannot equal 0. So that means it can be from negative infinity to 0 and then pick back up from 0 and go to infinity. Okay, but the, I guess, more complicated one is the f divided by g, because again, remember our rule, set denominator not equal to 0. Well, this denominator, that's going to be a little bit harder or more difficult to solve. So 6x squared plus 7x minus 10. This is a quadratic. And to solve a quadratic, you can try to factor, or you could use the quadratic formula. The quadratic formula is opposite b plus or minus the square root of b squared minus 4ac all over 2a. You can use that formula, but technically we don't know that formula yet. We're going to learn that in a different unit. I'm going to use the factoring method, and I need to know what factors multiply to give me negative 60, and I got negative 60 by saying 6 times negative 10, but they have to add to give me 7, and I got that from the middle right there. Okay, so let's think about it. Negative 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12. I think the 5 and 12 can work, because what's going to need to happen if we're multiplying to get a negative, we're going to have two different signs. You're adding to get a positive, so what if you make the 12 positive and the 5 negative? They multiply to give you negative 60, they add to give you 7. So at this point, I can rewrite that denominator as 6x squared minus 5x plus 12x minus 10. And I got the negative 5 and the 12 from the factors that I chose. You could have also put plus 12x minus 5x. That would have been the same thing. But we're going to factor this by grouping. I'm looking for a common, a greatest common factor in that first binomial. So I forget about this one for a second. And it has a GCF of x. If I take an x out, I'm left with 6x minus 5. And now forget about this binomial and only look at this one. And 12x and negative 10 have a 2 in common that you can pull out, and you're left with 6x minus 5. Well, notice that my 6x minus 5, they're the same thing. So if I pull that out, I'm only left with the x plus 2. So now we're fully factored, and you set each factor not equal to 0. So 6x minus 5 does not equal 0, and x plus 2 does not equal 0, which really means you add 5 to both sides to get 5 does not equal 6x, and then divide both sides by 6. So x cannot equal 5 over 6, and x cannot equal negative 2. Why can't it not equal that? Because if you plugged it in, if you plugged 5 over 6 or negative 2 into the function, whenever you got to the denominator, both of those numbers would make that 0, and you cannot divide by 0, so that's why they don't work. Anyway, how do you write this answer in interval notation? Well, look, think about the number line, okay? Now, an answer of all real numbers would be from negative infinity to infinity. But here's negative 2, and here's 5 over 6. Put them in numerical order. X cannot be those things. It can be anything else, but not those things. So reading it from left to right, x could be, and let me write my answer in white, I guess. X could be from negative infinity to negative 2, but skip over negative 2, and then it can be from negative 2 to 5 over 6, and skip over 5 over 6, and then it can be from 5 over 6 to positive infinity.